Hello everyone, welcome to Mathematics Step by Step. I am Ying. So today we will learn to explain the advantages and disadvantages of various measures of dispersion to describe ungrouped data. Okay, so different distribution of the set of data, we will use different measure of dispersion. Okay, so later on we will explore more on this. Measure of dispersion measure the distribution of a set of data. The range is the measure of dispersion easiest to calculate. However, the range cannot provide a good overview of how data is distributed. Okay, so I believe you guys still remember how to find the range. Range is the largest value minus the smallest value. Okay, in cases where there's an outlier or extreme value, the interquartile range would be more appropriate measure of dispersion to show the distribution of the data. Standard deviation is usually used to compare two sets of data. In general, low standard deviation indicates that the data is dispersed close to the mean, while a high standard deviation indicates that the data is dispersed far from the mean. Okay, so let's go through this example 10 together. Calculate the range and interquartile range of the set of data. So range is the largest value, which is 40, minus the smallest value, which is 10. Okay, so 40 minus 10 equals to 30. Then now we want to find the interquartile range. So we can see that this set of data is already arranged in ascending order. Okay, so now the median is here, 19. Okay, then first quartile would be 11, third quartile would be 21. Okay, so interquartile range is 21 minus 11, which is 10. And in this case, interquartile range is the most appropriate measure of dispersion because the existence of the outlier 40. Okay, so what is an outlier? Outlier is an extreme value. Okay, we can see that this set of data mostly are distributed from 10 to 20 something, but this 40 is an extreme value in this case. Okay, so that's why in this case interquartile range is a better measure of dispersion. Then now let's go through this example 11 together. The table below shows the achievements of two pupils in 5 physics tests. So Aiman and John. So these are the 5 tests. One of the pupils will be selected to represent the school in a physics quiz competition. Determine who is eligible to be selected and justify your answer. So in this case, you want to compare the performance between two pupils. Okay, we are comparing two sets of data. So in this case, a standard deviation would be a more appropriate measure of dispersion. Okay, so first of all, we will calculate the mean. So mean, we will add up all this, then divide by 5 for the case of Aiman. Okay, so we have got the mean 69.8. Then we'll find the standard deviation. So the sum of the square of the scores, okay, then divide by 5 minus mean square. This is the formula for standard deviation. Okay, then square root. Okay, if you have forgotten about this formula, you can refer to my previous video. Okay, so the standard deviation is 17.67. Then for the case of John, again we'll find the mean first. We'll sum up all this, then divide by 5. So this is the mean, and then sum up the squares of all these scores. Okay, then divide by 5 and minus mean square, then square root of it. Okay, this is the formula for standard deviation. So we have found the standard deviation equals to 7.574. Okay, so now let's compare and see. Aiman's score is having a standard deviation of 17.67, whereas for John, the standard deviation is only 7.574. So John will be selected to participate in the physics quiz competition because John's score is having a lower standard deviation. So this implies that John's achievement is more consistent. Okay, so now we have came to the homework again. So go back, you guys will do this self-practice 8.2b so that all the knowledge that we learned today belongs to you, okay? Practice makes perfect. So if you are struggling in completing all this homework, I've prepared an online course for you guys. It is a step-by-step guideline in helping you guys to complete all this homework in the textbook, including the comprehensive practice at the back of each chapter, okay? So coming next, we'll learn to construct and interpret the box plot for a set of ungrouped data, okay? So do not forget to subscribe to my YouTube channel so that you do not miss out any of my upcoming videos, okay? I'll see you in the next video. Bye bye.